Thank you so much for sharing that with us, Carl. So I'd like to go to some of the classrooms that are sitting out there waiting to ask you questions. So how about we start in Georgia, and then we're going to go to Indiana, and then we'll jump over to Alaska. We'll do two questions from each. Okay, so let's start at St. Luke School, while Mount Tabor Elementary. You can go ahead and get ready because we're going to come to you next. Let's start. St. Luke.
What caused you to enter your field of study?
Well, I'll take that first, and then Carl can answer. So, I'm a geologist, and I love to do science, and I like to do science outside. So, being a geologist lets me travel around the world, lets me do science, and lets me be outside doing my science.
I think water is so important both for our uses and for the ecosystems that it's just really interesting for me to be a part of managing the water on the national forests.
Great. How about a second question from you all at St. Luke School? We're ready for you.
Why is there more water in the mountains?
Because kind of what I was talking about earlier, because the mountains actually change the weather, they make more rain and snow fall in the mountains. Also because the mountains are colder, particularly in the winter, rather than evaporating or running off, much of that snow is stored during the winter months, and then it becomes available during the summer.
And you can think about it also as the moist air that's coming off of the oceans. As the wind moves that moist air, it carries it towards the mountains where it then gets cooler, as Carl's mentioning. And as that moist air gets cooler, it precipitates or it rains or snows. And that's why the bulk of the water is concentrated in the high mountains.
All right, excellent. Thank you so much for those explanations. We're going to jump from Georgia to Indiana. Mount Tabor Elementary, you all ready for us? We're going to take two questions.
Ellie, go.
How does nature
I couldn't hear that question. Can you repeat it?
How does nature filter water to make?
How does nature filter?
Okay. Well, I was talking about the importance of the forest floor. There's a bunch of material out sitting on the ground on the forest. There's dead and live plants. There's decaying organic material, and there's also the soil itself. Now, all those things may seem kind of yucky, but they really serve to provide a sponge that soaks up the water and holds it in the forest and slowly releases it, and as a filter to clean the water as it's traveling downhill toward the streams.
Do you all have a second question ready for us, Mount Tabor?
How much fresh water?
How much fresh water do you take? How much fresh water per day?
That's a good question. It's kind of a complicated question too, because you have to think about what you mean by need. We probably drink maybe a little less than a gallon of water a day, but think of all the other water that you use. Do you water your lawn? Do you use water to brush your teeth and run the dishwasher and wash your clothes? And all of those things. On average in the West, we use about a half an acre foot of water a year. So if you imagine a football field filled 6 inches deep with water, that's about how much water your family uses.
Another thing just to think about it is that there's water being used to provide, for example, the cloth that you're wearing. If you're wearing blue jeans, the blue jeans are made of cotton. The cotton is grown with water. When you think about the meals that you're eating, the bread is made from grain, the meat is made from beef. That all requires water. So there's water being used in many different ways every day by all of us.
Great. Classrooms. Thank you so much. We will go back into classrooms in a moment. So would the Toke School go ahead and get ready? But I'm going to take a few questions from our online audience. Remember that we're on Facebook, YouTube, and even freshwaterlive.org is where you can ask questions. The first one coming from online is from a teacher slash naturalist in Virginia. And that's Mary. She's asking, are stream restorations successful?
Like everything else, some of them. I think that we haven't been thinking about restoring streams for very long in the bigger scheme of things. We've probably only actively been doing it for the last 20 or 25 years. And I think that just like everything else, we're getting better at it as we go. So I think that, yes, largely stream restorations are successful. I think that sometimes because the problems show up in the streams, we think that the solutions are in the streams. And sometimes we need to take a step back and look at what's going on in the watersheds and think if there are restoration activities that can happen in those watersheds that will make the streams healthier.
Ooh, thank you. We're going to jump from Virginia and go to South Carolina. We have Mrs. McLean's cast. The question is, how long does it take to clean the water? And what kind of germs are there in water?
Well, we've been cleaning up the water around us since I've been living, watching it. I've looked at river systems that started out when I was a young child. They were polluted. There were no fish living in them. And we've cleaned up those river systems tremendously, and it's happening on a worldwide basis. There's a wide variety of pollutants that can get into water. It used to be rivers were thought of as places where you could just dump your garbage, throw your waste. Today, through education, we've learned that the river systems are vital to the health of all of us and that we want to share that water regionally. So we've cleaned up the rivers. We've taken the garbage out of the rivers in Colorado. We've had volunteers, students have gone to the rivers. They've cleaned up the rivers. We've had scientists looking at how the water flows into the rivers. We've cleaned up the chemical pollutants and the biological pollutants that are in the waters flowing into the streams. In many communities, you'll see there's signs that tell you, that warn you not to pollute the river systems, not to pour waste on the ground that's going to flow into the rivers. We're cleaning up the rivers worldwide, and wherever you go, the water is getting cleaner.
Great. I'll take one more online question. This one's coming all the way from California. What's the best way to capture fresh water in a drought-stricken area?
Well, for example, the area right behind us is a reservoir. We store water. The water arrives when the snow melts in the spring, and we store the water in reservoir systems so that we can use it year-round. So one of the best ways that we have to store water is in reservoir systems. And for those of you in California, we store the Colorado River system, for example, in Lakes Powell and Lake Mead. Those are big reservoirs that influence the storage of Colorado River water, some of which goes to California.
Great, thanks. Hey, let's go on all the way up to Alaska. How about Toke School? Are you all ready? Let's get 2 questions from you all up there.
Okay. Okay, yes, we're ready. Go ahead, stand up there. Take it. See, Bella.
What is aquatic?
What's the newest aquatic creature you found? What's the newest aquatic creature you've found?
Oh, there's
Repeat the question.
the question is, what is the newest aquatic creature that we've found? We've just recently found a very rare little stonefly called the Arapaho snowfly that lives only in a few streams along the Front Range of Colorado. And it's got a really funky life cycle. It spends most of its life living under the snowpack, and for much of the summer, when we could find it, it actually drills down and lives in the wetted soils around the stream, which is probably one of the reasons that it's been hanging around for a long time, and we only recently found out that it was there.
I love it. So science is still uncovering new things every day. Thank you, Toke School. How about another question from you guys?
What else can pollute water?
What else can pollute the water?
What else can
Pollute the water.
Oh, so what else can pollute the water? Well, a lot of the pollutions that come into water come from the activities of man. If you think about the things that we do on a day-to-day basis, we have a variety of ways that we can inadvertently make the water polluted. One of them, for example, is if we don't pay attention to where our sewerage goes. And around the world, we're paying more and more attention to wastewater, the water that leaves the home. After you take a shower, you flush a toilet, where does that water go? And that water goes, in many cases, to waste treatment plants where they clean the water up so that it can be allowed to go back into the stream systems and be reused by other people as well as by the natural environment.
All right. So I'm again encouraging everybody that if you have questions and we're not getting to you fast enough, go ahead and pop those questions into the chat. We're happy to take them there. We're going to stay with Alaska for a minute and go to the North Star School. Go ahead and get yourself situated. Speak nice and loud and clear. We'll take 2 questions from you guys. You look great, and we're ready to hear from you also.
Yeah. We ran out of fresh water. Could we run out of fresh water?
So the question was, could we run out of fresh water? And there is a limited amount of fresh water on the Earth's surface, but we share that water and we reuse the water. So it's unlikely that we're going to run out of water, but the water is not evenly distributed across the surface of the Earth. And down here in the lower 48, we've got to be concerned because many of the people live in drier areas. For example, we've got a lot of people living in Arizona, in Nevada, Southern California, areas where there's not a lot of fresh water locally available. And we actually share the water from Colorado with people living in those areas. And so if we can share it carefully and be conscientious with how we use it, there's plenty of fresh water for everybody.
Great. How about a second question there from North Star? We are ready for you.
Yeah. How can we prevent animals from polluting the water?
How can we prevent animals from polluting the water? The hunter.
I don't really think of animals as polluting the water too much. Now, I think that sometimes there are things that occur in water naturally that can become problems if there's too much of it. So that, for instance, in where I live in Fort Collins, Colorado, on the other side of the mountains that are behind us, we have lots and lots of geese in the that stay there in the winter, and the geese poop in the water. And that can become a problem locally, but that's what geese do. So it's not so much that we have to stop the geese from doing it. It's just that there may be too many geese at a particular place that we have to think about that as a potential source of pollutants.
Amazing. Our questions have come from Georgia all the way up to Alaska. I'm not exactly sure where this next one comes from, but it's a great one. With icebergs melting, are you getting good water from them?
Well, the icebergs are melting at sea, and so there is fresh water that comes from those icebergs, but we do not use the water from melting icebergs. So the majority of the water that we're using is surface flowing water, fresh water that flows in rivers and streams, and we find it in lakes and reservoirs.
Great. Folks at home, in your classrooms, go ahead and keep coming up with questions. I think we'll have enough time to come back to you again. So keep these questions coming. We'll take another one from the chat, though. This one is, can we use solar energy to desalinate water? This one has come up a number of times. I want to make sure that we hear it from you all.
Yes, so we do use solar energy to desalinate water. The desalination of water, which is taking salt out of salty, brackish water or ocean water, involves a lot of energy. And there are many parts of the world where we're experimenting with desalination, taking the salt out of the water, and that energy is derived from wind turbines, solar panels, as well as from natural gas, oil. So we use a lot of energy to desalinate water, and depending on where you are, different kinds of energy are available. I'll just give you one example. For example, in Western Australia, there's a water shortage in the town of Perth, and they're using wind turbines. So they're using the energy from the wind to run the desalination plants in Western Australia right now.